Hi, this is Richard C. I'm a math tutor at Wyzant, answering a question submitted by a student. This is a question regarding vectors and fairly early material in vectors. This student's going to be learning a lot more about vectors before the course is over, I would think. This is a topic that usually appears in pre-calculus. So I'm just going to get started here. So the vector, you know something's a vector because you put a little sort of arrow looking thing over it, and that's equal to 2 comma negative 2. Now they're also interested in negative 3v and 1/2 v. So I'm going to use different colors here for each of those so that we can graph them easily later. So negative 3v is exactly what you would expect of a scalar, which in this case is negative 3, times a vector is going to produce exactly what you would expect. It's going to be negative 6, positive 6. This is coming from negative 2 times positive 2 times negative 3 to give you negative 6, and then negative 2 times negative 3 to give you positive 6. And then the other one is half v, and we'll choose another color here for that. So 1/2 vector v is going to have the coordinates 1 comma negative 1. That's coming from half of 2 is 1, half of negative 2 is negative 1. When we go to graph these vectors, it's exactly what you would expect. No surprises. We just draw an xy coordinate plane here. The original vector is going to be 2 comma 2. So there it is. That's v here in black. Negative 3v, put that in green. So that's going to be negative 6. Negative 6 is going to be roughly here, and then up 6 would be roughly like this. So we'll put that negative v here. So here's negative 3v, not just negative v. Okay. And then the last one in purple, 1/2 v. That's going to be 1 comma. Oh, my goodness, v is wrong. Excuse me, my goodness gracious. Excuse me, how I did that, I don't know. 2 negative 2, so it's 2 here and then down 2 here. So it's going to be roughly like that. So that's our v. Sorry about that. Notice that negative v is going to be on the same, it's sort of a flip, it's reflected over the origin, negative v, and then the magnitude or size of the vector is tripled. So that's the way a negative affects the vector. Okay, so hopefully I've got my head screwed on straight now. We'll finish this last one. So 1 negative 1. So it's going to be right here, and that lies on top of v would be 1/2 v. So you can see why I wanted to do this in color, so you can see things clearly, because 1/2 v and v are collinear. They lie on the same line, they just have different magnitudes, different lengths. Okay, so that's it for this one. Very sorry about that earlier mistake, but now we've got it all fixed up. So I'll see you guys next time. Bye-bye now.